Hello, everybody. Welcome back to my channel. I know I haven't done a video in quite some time. I've been sort of busily preparing for Christmas and then having Christmas, which was very enjoyable. And now I'm back to doing videos about science and so on. And this idea I've had for quantum gravity, which I thought I would explain to you now in terms of the luminiferous ether and explain why my model of quantum gravity is really sort of an updated ether model and why I think we need to return to the idea of the luminiferous ether, and why I think that a sort of ether model makes a lot of sense, really, considering the universe and considering what we observe in the universe and these sorts of things. So I thought, just getting into this right now, what is the luminiferous ether? This is an idea which was abandoned after the Michelson-Morley experiment back in the late 19th century, I think it was, and sort of moved on to special relativity in 1905, and moved away from ether models, which were abandoned eventually with great reluctance by the scientific community, and abandoned with great reluctance actually by Einstein himself. Einstein really wanted the idea of an ether to exist, and he actually described the fields in general relativity as being like an ether. So he was, very attached to this idea of an ether, in fact, and scientists in general were very attached to an idea of an ether for a very long time. But the idea has now become something of a taboo in physics. We can't really discuss physics in terms of an ether anymore, even though it's very much what we observe in nature. It's very much a decent way of thinking about the natural world and the cosmos and things. As being permeated by some sort of substance which allows for the propagation of light through it. So just recapping again on my idea for quantum gravity. What my idea for quantum gravity entails is that an electron density permeates the universe, but all massive objects are surrounded by a cloud of tunneling electrons, this sort of very ephemeral, mysterious, hard to detect cloud of electrons surrounding, say, planets, stars, galaxies. Each electron in the cloud appears for about a Planck time each time, then tunnels again to a different location to be replaced by another electron. These electrons, they influence the behavior of light around objects, and they, of course, create a force of attraction between objects as well, since an electron from one object can tunnel to within the electroweak range of the protons in another object and transmit a force of attraction between that electron and the proton, so you get this macroscopic force of attraction between bodies in nature that way. And this is somewhat similar to an idea of the luminiferous ether, but it's not really the same thing at all, since a luminiferous ether in the traditional sense was something that was thought to be static in relation to objects moving through space. So it would be just something that permeates all of space, is static in the background, and is dragged around by objects moving through space. So the Michelson-Morley experiment is this interferometry experiment looking for changes in the speed of light between the ether in the background and, say, Earth in the foreground. So it was trying to measure the influence of the ether wind over the speed of light when the Earth is perpendicular to the ether in the background to when it's at right angles to the ether in the background. So this experiment, of course, came up negative. We didn't find any changes in the speed of light or any significant changes in the speed of light with the ether in the background. And more recent experiments, an experiment in 2009, for instance, concluded that down to the 10 to the 17 level, I think, that there's nothing like an ether in the background influencing the speed of light. So that idea has again been abandoned. But I would contend that they didn't get the idea of the ether right to begin with, and that the ether really is something which is propagated by objects in space. So, for instance, Earth is surrounded by its own cloud of electrons, its own ether, if you like, formed of electrons. The Sun, likewise, is surrounded by an ether formed of electrons. So, the light is always propagating through this ether. So, it's not something which is dragged around by objects in the background. It's not something that's stationary. to objects in the background. It's something which is attached to objects within the background and that's propagated by objects in the background. So really, you wouldn't detect any changes in the speed of light using an interferometer at all, really, with the sort of ether that I propose. What you could do is detect changes in the speed of light near very large masses, or in very strong gravitational fields. You'd expect to see light slow down, I think, which I think is what we expect really from objects in the background anyway, via general relativity and via just the classical physics actually that we're aware of also that's pertinent to those situations, such as when you get very close to a black hole, obviously there's this huge accretion, there's these huge accretion disks of material surrounding black holes. So for that reason alone, light would slow down close to a black hole. It would be traveling through all this other matter in the background, this medium of stuff there in the background, and the speed of light would be getting slowed down by those objects in much the same way as that the speed of light slows down when it travels through glass or water or something like this. So the ether that I propose is somewhat different to the original idea of the luminiferous ether, but nonetheless it is probable, I think, and I think that we do need a sort of medium through which light can propagate. I think, if you sort of see this idea of the whole of the background being permeated by tunneling electrons, you can see how light waves can propagate through that in sort of zigzag patterns. There's at one sort of vertex on the zigzag, an electron is absorbing the light particle, then it's tunneling away again to be replaced by another electron with another light particle which gets emitted from that electron, travels down again, gets absorbed by another electron, the electron tunnels, a new electron replaces it, spits out a light ray, and through these sorts of considerations extrapolated to large distances in space, we can sort of see how redshift and blue shift might be occurring. So, you've got an object emitting light, such as a star, for instance, traveling towards us in space. It'll be emitting a constant amount of radiation, but there's increasingly fewer electrons in the background to absorb all that radiation. So in the interest of trying to get back to their ground state, the electrons in the background, these would be kicking out more high energy blue shifted photons. So we'd see more blue light coming from an object that's coming towards us versus red light for objects moving away from us. Since an object moving away from us is traveling, there's a progressively greater and greater amount of background electrons in the intervening space. So in the interest, yet again, of getting back to their ground state, the high energy photons emitted by the object, those are trapped more readily by the background or absorbed more readily by the background. So we only see red light emitted from these objects, for example. So I think there's a huge amount of potential here with this idea, and it's become taboo in physics really to think about the luminiferous ether, and to think about it's become taboo, I think, to think about it in its original conception. The original ether theory was wrong. It was wrong. It's disproven. That's fair enough. But I think what we need in physics is really to go back to these sorts of ideas and update them in terms of what we know now. And a static, stationary ether in the background, that is a wrong-headed idea. It turned out to be non-existent. But an active, dynamic ether in the background and in the foreground, if we're thinking about the Earth and the Sun system, for example, the Earth propagating its own ether field around it, we could, very much think of that, and the light rays being dragged along with the Earth, and so there's no changes in the speed of light due to the Earth traveling perpendicular to an ether in the background, since the ether is also in the foreground as well as the background. And we can think of it this way, and I think get around the problems posed by the Michelson-Morley experiment quite effectively. And maybe it deserves a longer treatment in a better video, and I'll try and at some point I'm still going to try and make videos about this topic, which include things like diagrams and equations and pictures and so on, and edit it all properly and try and do it all properly once I get the equipment to be able to do that. And yeah, I'll return one day with a proper video explaining all this stuff. So thank you very much for watching. Bye bye bye. Love you lots. I'll see you soon.